Hello everyone. So this is the pre-lab discussion for the hemocytometer, your red blood cell counting, and manual WBC counting. So our objectives for this pre-lab discussion are the following. So at the end of the activity, you can be able to correctly perform the manual procedures in determining the cell count with competence vis-a-vis biosafety and proper waste management. You will be able to analyze the factors that affect patients' cell counts, evaluate the correctness of the technical procedures in performing cell counting determination through manual methods, correctly interpret cell counts of a patient, and identify the clinical significance of a patient's cell count. So, nowadays in the laboratory, we do not routinely perform manual counting. But of course, if the machine fails or if there's a problem with the machine and we urgently need to release the CBC, most likely we can do manual cell counting. So although laboratories avoid performing manual procedures, your manual cell counting is used on certain occasions, particularly if there are problems encountered in the results released by the machine. So your manual cell counting is used in the following circumstances. So first is to, of course, check the validity of the electronic method. So whatever result is released by your machine, it can be verified by your manual cell counting. So of course, if you are doubtful, even if you have run the sample multiple times and it's still, its results did not correlate with each other, or it did not validate or verify, or it did not correlate with each other, so most likely you can perform manual cell counting. So again, validity check for electronic counts in patients with profound leukopenia and thrombocytopenia. So this is also one of the cases wherein you perform manual counting if the machine can no longer count the cells because it's too low or if it's too high. Ganyan. So remember, we have this what we call your linearity. Kindly review that term, linearity. So in all machines, there has to be a linearity, and you need to know that because whatever is outside the linearity of the machine, it cannot be read. So particularly if the WBCs or RBCs are too low, you can perform manual counting because it cannot be read by the machine. So for blood specimen with platelet counting interferences, for example, if you have giant platelet, okay, so most likely it can actually interfere with the WBC counting. Why? Because your giant platelet or your giant platelet can actually be read as WBC. So it can cause interferences in your results. So another thing is it can be a backup method, particularly if you are doubtful of your machine generated results. So in the picture you can see here, this is the field of your hemocytometer. So your hemocytometer is composed of squares, okay? So we will be focusing, or we will be discussing this one in details, but I need you to know that the four big squares are used to count WBCs, okay? So the blue ones are used to count for the WBCs, while the red circles are used to count red blood cells, okay? The orange circle dyan, okay? And as you can see, look at the flow or the direction of your counting. It should begin from left to right and then from right to left. So again, this method, as I have mentioned in the previous pre-lab discussion, this is what you call your battlement technique, okay? So you have to count cells from left to right, then right to left, then left to right, then right to left. Okay, so again, there are four big squares, and this one is for WBC count. And then you have your small squares. We have 5 small squares. That is for your RBC counting. So the general procedure for your hemocytometry is, of course, first you have to do specimen dilution. So if you want to count for the red blood cells, then you're going to use a pipette specific for the red blood cells and diluent specific for red blood cell counting. The same with your WBC count. So if you will be counting WBCs, then you use the pipette specific for the WBC, and then the dilution, or the diluent rather, the diluent that you will be using will be specific for WBCs. So after diluting the specimen, you're going to charge the hemocytometer. Charging the hemocytometer means you're going to put a sample, a volume of sample into your hemocytometer. That's what we call your charging. So, and the last one is your microscopy, or viewing the ruled areas. So all of these procedure, we will be talking about this one by one. So let's go to step 1. When you dilute your specimen, it is because you want to avoid crowding of cells during the manual counting. You count the cells, and you need to make sure that the cells are not overlapping. In fact, ideally, the cells should have an enough distance from each other. Hindi talaga sila magkadikit. Now, later, I'll show you a picture of how cells should appear under the microscope when it is charged onto your hemocytometer. So again, the things or materials that you need for blood dilution or for sample dilution are as follows: your RBC pipette if you want to count manually for the RBCs, and the WBC pipette if you want to count manually for the WBC. And then you also need to know the diluting fluid. So as early as now, you need to review what are the different diluting fluid for RBC and WBC. Okay? For example, guys, if you want to count WBC, the most common diluent we use is your acetic acid. Why? Because we want to count WBC, we want RBCs to be gone, right? So what we can use is your acetic acid. Your acetic acid will destroy your RBCs, leaving only the WBCs in the solution. So when you say dilution, most likely it will eliminate the cells that are not involved in the counting. So for example, again, if I'm going to read or count WBCs, then I have to use your acetic acid, because your acetic acid will destroy the RBCs, and at the same time, it will enhance the nucleus of your WBC. So that's just an example, no, of your reagent or diluting fluid. Now let's get to know your RBC and WBC pipette. So as you can see here, they look like the same, but the difference is that the bulb it contains, or the capacity of the bulb. So as you can see in your RBC pipette, the bulb can contain 100 units, while in your WBC pipette, it can contain 10 units only. So if you will try to look at the actual picture of your the pipette, so it will look like this. So look at this one. So this pipette here, since it has a bead that is color red, therefore this is an RBC pipette, or a red blood cell pipette. And the other one is white bead, therefore that's a white blood cell pipette. And if you will try to compare the bulb size of your RBC and your WBC, so it's obviously different. It's bigger in your red blood cells pipette compared to your WBC pipette, because that means now your RBC pipette can hold 100 units of your blood sample, or your solution rather, while your WBC pipette can hold 10 units of it. Okay, so that is why when you try to get the sum of the whole volume inside the pipette, you're going to add 1 unit from this stem, okay, and then your 100 units from the bulb. That's all in all 101 units. That's for the RBC pipette. While for WBC pipette, as you can see, 1 unit from the stem and 10 units from the bulb. All in all, that's 11 units. Okay? So, most of the time, you sip the blood at 0.5. Okay? So, this one. Most of the time, you sip the blood up to 0.5, and then your WBC up to 0.5 pa rin. So, anyway, later, I'll explain the step-by-step how do you get a blood sample from the tube or your EDTA, no, to be used for cell counting. So again, this one, I'd like to emphasize that you're going to take blood up to mark 0.5 only. The same with your WBC pipette. So both of them, you have to just collect blood from 0.5 mark. After that, you're going to wipe off the excess blood on the external portion or the exterior of the pipette, so that your 0.5 will just be 0.5. Okay, it will not include some more tinge of blood or an excess of blood present on the outside of the pipette. So what you need to do is to wipe off with the gauze, and then if there's no contamination on the outside, that's the time you sip a diluent from a container, okay? So that the diluent will get inside, and then it will allow the blood to be mixed with the diluent, particularly here in the bulb. Okay? So remember, this is connected to a suction rubber tubing. So your suction rubber tubing is connected to a barrel. Okay? So in the face-to-face conduct of this laboratory, you will appreciate it more. So remember, before you sip blood up to the 0.5 mark, you have to make sure that the pipette is not contaminated. Okay? So how do we make sure that the pipette is not contaminated? We usually wash it with acetone. Okay, so when we want to remove the sample inside, because of course you will not only be performing CBC or WBC count or red blood cell count in just one patient, so you will have multiple patients. Okay, so in that case, for you to be able to reuse your pipette, you have to use the acetone, okay, to clean the pipette. Okay, so that there will be no contaminants. As I have also mentioned, I'll emphasize again that you have to remove the excess blood on the exterior of the tip of the pipette, so that you will only get a 0.5 up to the 0.5 mark, nothing else. Okay, so the rest of the fluid that will be entering the bulb will be the diluting fluid already. Okay, so I mentioned this one already. So if you're wondering why 101 ang mark ng WBC, I mean ng RBC pipette natin, while sa WBC is 11 ang mark niya, that's because the bulb of your RBC and WBC are totally different in volume. So mas malaki yung RBC compared sa WBC. So but if you will try to check, the capacity of the red blood cell na bulb is only 100. Nasaan yung 1? Kasi 101 ito eh. Nasa stem niya. Okay, the same thing with your WBC. The capacity, the volume capacity of your white blood cell bulb is only 10. So, nasaan yung isang 1? Because 11 dapat ito. That's present in your stem. Okay, so, next. So, I mentioned this one already. Okay, so let's go to your differentiation of your pipette. So, your RBC has a larger bulb. I mentioned this one already. Your WBC has smaller bulb. The color of the bead is red while your WBC is white. So, please go through with this information. Okay, you can pause the video and then try to familiarize or memorize the differentiation between the RBC and the WBC pipette. But I'd like to emphasize, guys, the calibration. They have the same up to the stem, but it will differ once it reaches the bulb. So your RBC has up to 101 mark. That's because the bulb can accommodate 100 units, while your WBC is only up to 11 mark because the bulb can accommodate 10 units only. So it will also be evident when you check the dilution of your RBC pipette and WBC pipette. As you can see, 1:200 the dilution of your RBC pipette, while your WBC is only 1:10. Okay? So, now let's go to your diluting fluid. I mentioned earlier that you will only sip blood up to the 0.5 mark. So you have to wipe off with gauze the excess blood from the exterior of the tip of the pipette, just to make sure there is no extra blood that will get inside the pipette. So after that, if you're already sure that the blood is up to the 0.5 mark without excess, you are going to sip a diluting fluid. For example, if you're going to count for RBCs, then you have to use diluting fluids that are isotonic in solution so that it can prevent the lysis of your RBC. When you say isotonic, that means normal tonicity. Okay, it is somewhat closer to the tonicity of the blood. Okay, and what can we use? We have your Hayem's, Gower's, Toyson's, and Bethel's. Okay, so your Hayem's, Gower's, Toyson's, and Bethel's. The most common diluting fluid for RBC in the laboratory is your normal saline. Okay, your normal saline solution. Okay, while your WBC, again, the diluting fluid should lyse the RBC. Therefore, what you can use is a hypotonic solution. A hypotonic solution so that your RBCs will swell and at the same time it will burst. So, leaving only the WBCs in the solution. So, if the only WBC ang natira, then it will not be difficult for you to count the WBC. Plus the fact that because it's a weak acid, it will enhance the nucleus of your WBCs. Remember, it cannot lyse nucleated RBCs. Even in the machine, no? Kahit sa machine, most nucleated RBC, kinakount sila as WBC. So, that's the reason why you have to make sure talaga na hindi nucleated RBC ang kinakount ng ating machine. Okay, so let's review your dilution. Dilution is a very simple topic. All you have to do is to not get intimidated with the formula of dilution. So when you're given with a problem, when you're given with a situation, always make sure to just memorize the formula of dilution. Kahit baliktarin ka pa, if you know the formula of dilution, you can always get the right answer. For example, if I'm going to give you the total volume of the solution and then I'll ask you, I'll give you the dilution, I'll give you the total volume solution, then what's the missing info there? The volume of solute. So what you're going to do is to just cross multiply. Dilution times total volume, and then that's the volume of your solute. Okay? So all you have to do is just to memorize the formula. And the formula is dilution is equal to volume of solute divided by total volume of solution. Remember that your total volume of solution is the sum of your solute volume plus the solvent volume. Okay, and this one is reported as 1:something. For example, 1:3, 1:4. So since we are talking about dilution, that's normally the manner of reporting, particularly in your dilution. Okay, so now, let's try to compute for the dilution. So for example, if you have 1 ml of solute, okay, you have 1 ml of solute and 5 ml of diluent. So if you will check the formula, anong sabi sa formula? Dilution is equal to solute divided by total volume. So your ang tawag niyan? Computation here would be, so dilution is equal to 1 ml divided by 6 ml, di ba? 6 ml kasi nga ang nasa denominator natin should be the total volume, which is the combination or the sum rather of your solute and solvent. So in that case, this will be your ang tawag niyan? Solution, no? So you can have an answer of 1:6, 1:6 or 1/6 or 1:6. Parehas lang yan sila. So anong ginawa natin ulit? Wait, I'll try to check if I can use a pen. So dilution, yan, dilution is equal to 1 ml over 1 plus 5. Okay? So, in this case, your dilution would be 1:6. You can no longer simplify this one as this is the simplest form already. So, most of the time, if 1 na yung nasa numerator, most of the time, hindi mo na yan kailangang i-simplify pa because that's the simplest form already. So again, do not get intimidated with dilution. Okay? So, whichever of the three are all but the same. So in short, kahit anong manner ang pagkasulat mo, as long as you got the right answer, then there's no problem. Okay. So, let's go with your RBC dilution. So in this case, the computation for your RBC dilution is your solute less the 0.5 units or 1 unit. And then the total volume of the solution pertains to the volume capacity of the blood, which is 100 units. And then solvent, just subtract 0.5 unit from the 100 unit. So, bakit ganun? Kasi nga, ang blood lang na sinip mo is until 0.5. So, the rest of it up to 101 mark is your solvent. Okay? So, ibig sabihin, ang solute mo this time is the blood. So, since you only got 0.5 mark of the blood, and then you sip a diluent up to 101, so that means you have 0.5 units of RBC is to 100 or 100.5 units of your solvent. Okay? So, from the fact that yung solute natin is 0.5 and the total volume of solution is 100 microliter. Parang kumbaga in simple terms, ganito lang yan. 0.5 solute divided by the total volume 100. Okay? So, in that case, simplify mo lang. Ang mangyayari is that 1 is to 200. Okay, napakahaba na ng explanation dun sa isang slide. But this is it, no? So, you just have to use the formula for dilution. Ayan. So, your dilution, again, your dilution is equivalent to solute divided by solvent. So, in that case, your solute, divided by total volume. So, in that case, your solute is 0.5 and your total volume this time of the solution is 100. All you have to do is to just, put this one into a whole number. This is not a whole number kasi may point, may decimal. So, you have to divide the numerator and the denominator by 0.5. So, divide mo yan ng 0.5, 0.5. Wala nang y. Okay? Kanina may mga y. And it will make your life complicated. So, as you can see, you just simplify this one into a whole number. 0.5 divided by 0.5, that's 1. 100 divided by 0.5, that's 200. So, this is the reason why we came up with a dilution of your RBC na 1 is to 200. Okay, now, let's go to your WBC dilution. O yun, shortcut ko lang. Okay, so it's the same thing, guys. You just have to follow the formula for dilution. Since the volume of your solute is 0.5, okay, and your total volume of the solution is 100, then get the whole number of this one. You just have to divide both sides by 0.5. Okay? And then if you will divide both sides by 0.5, you can come up with a 1 is to 200. Okay? Sige. So, let's proceed to your WBC dilution. It applies the same principle except that the total volume of the solution this time is 10 microliter. It's not 100. Okay? So, ang gawin mo lang is 0.5 divided by 10. Hindi na 100. Okay? So, in that case, you can come up with 1 is to 20. Okay? 1 is to 20 na dilution. O yun, compute nyo daw. So, kindly compute that one para naman, you can first-hand, experience how computing or how to compute your dilution. Okay, so let's proceed now to your general procedure. For specimen dilution again, let's proceed now to your hemocytometer charging. So, how do you charge your hemocytometer? So, as you can see, this is your hemocytometer, guys. Meron tayong anterior chamber and posterior chamber, or chamber number 1 and chamber number 2. So, ang gagawin mo is i-charge mo, like, lalagay mo dyan, dito lang sa gilid, dito sa edge. You will put a volume of sample, and then this sample will try to spread out. If you fill in niya yan, bawal mag-leak sa kanal. Bawal. Okay, dito din sa kabila, if you fill in mo yan using your diluted sample. By the way, meron tayong mixer ng pipette ha. May mixer tayo ng pipette, pero I'd like you to know na may ibang lab na wala talagang mixer. So, all you have to do is to just shake. Meron naman siyang bead. No? The bead itself will help you mix the solvent and the solute. So, again, this is your hemocytometer. So, this is a calibrated hemocytometer. That means when you try to check inside, meron niyang mga lines. So, ito naman, yeah, one chamber yan and the other chamber ito sa kabila. So, lalagyan mo yan sila ng sample on both ends. And then, make sure na walang bubbles. Ayaw natin yan. And at the same time, the number of cells on the other side should coincide with the number of cells on the other side. Kasi nga, same sample lang naman sila. Okay, this is actually a validation technique wherein you try to compare the number of cells on the other counting chamber and this one is the other counting chamber. So, ang tawag natin dito is counting chamber. Counting chamber. Okay, you will charge the sample in one counting chamber and you will charge the hemocytometer on the other counting chamber using the same sample. So, yung sample mo dito sa taas, yun din ang sample mo sa kabila.
What is this thing? This is a hemocytometer. It's used for counting cells and was originally used for counting blood cells. Hemocytometer. Blood cell measurer. Counter. The hemocytometer is a thick microscope slide with two counting chambers on reflective sections. Each chamber is divided into 9 main squares with a series of etched lines. These squares are 1 millimeter by 1 millimeter or 1 millimeter squared. When a glass cover slip is placed on top of this chamber, each of these 9 squares contains 100 nanoliters of liquid.
Okay, I think the video is not full or hindi siya fully loaded when it was inserted here. So I'll send you the video na lang. So I'll send you separately the video for this one. So basta yun yung hemocytometer charging natin. So as you can see, meron tayong dalang counting chamber and yung sa taas niyan merong cover slip. Okay? And when you charge the hemocytometer, dito mo siya ilalagay yan on both ends. And then you just allow the sample to spread out. Pag hindi yan na charge ng maayos, magkakaroon ng problem sa counting mo, magkakaroon ng erroneous result. So again, when you dilute the sample, you have to dilute it properly and at the same time charge the hemocytometer properly. So that means you have to fill in the counting chamber in full nang hindi naglilik, hindi naglilik dito sa kanal niya. Okay, as I said guys, the depth this one is your counting chamber yan. Counting chamber ito. So, dito mo siya ilalagay yung sample. So, yan. That's a sample introduction point. And then, there has to be a cover slip on top of it. And as you can see, meron siyang depth na 0.1 mm. Okay? 0.1 mm ang depth niya. Baka itanong yan sa inyo. Okay, know the depth of your hemocytometer. Okay, so this one again is your hemocytometer. As you can see, meron siyang counting chamber dito, counting chamber on the other side. This is your cover slip. And this one is yung kanal, no? Nakikita natin, the moat. Okay, that's the term pala, no? The moat. So, the depth between the cover slip and your counting chamber is only 0.1 millimeter. Okay, do not forget that one. I mentioned earlier, no, that this one is your WBC counter, WBC counting area ng WBC, and this one WBC din. Nasa gitna yung 5 red na cells, na squares, dito mo i-count ang red blood cell. Dito red blood cell din, this one is red blood cell, red blood cell, red blood cell. Sa isang buong malaking square, that's 1 millimeter ang kanyang capacity. Okay, so if this is 1 millimeter, therefore, one small square is only 0.25 millimeter. So, isang RBC counting square dito, ito. Di ba 5 sila? So, 1, 2, 3, 4, 5. So, 5 dapat yan. So, for each of the counting square dito, sa RBC natin, that's 0.25 millimeter. Yan. So, that's for your RBC. This one, 1 millimeter naman sa ating WBC. 1, 2, 3, 4, 5. So, 5 yan lahat, no? So, if i-zoom in natin yan, ganito itsura niyan. So, sa loob niya, it's still divided into 4 pa talaga. So, if this is 0.25 already, kung 0.25 yung ating area nitong maliit na square, so, ilan ito lahat? 2, 4, 6, 8, 10, 12, 14, 15, 16. So, 0.25 divided by 16 squares. So, meaning to say, sa bawat square na nandito, that is 0.15 Okay, so tinatanong yan sa mga exams ninyo. So in each square, okay, yung maliit, in each small square of the RBC counting area, ilan ang area. So that's 0.156. But all in all, itong area na to, this is 0.25. Okay?
After a blood specimen has been diluted as directed by manufacturer instructions and the vial has been mixed, a small amount of specimen is loaded into the hemocytometer chamber for counting. Materials needed for this process include hemocytometer with cover glass, diluted specimen, alcohol and lint-free tissues, timer, moist chamber, and a microscope with 10x and 40x objectives. The chamber is composed of the hemocytometer and cover glass. This cover glass is specific for the chamber and is optically flat to ensure a consistent depth over the entire counting chamber. The center section of the hemocytometer has three components: the platforms, the moat, and the bridges. There are two platforms, one on each side of the chamber. As you look closely at the platforms, you should be able to see a grid on each side. There is a V-shaped groove on each side that is used to help load the specimen into the chamber. Around each platform is a moat which separates each platform from the other. Beside the moat on each side are the bridges. These raised sides provide support for the cover glass, and the distance between the platforms and the cover glass is 0.1 millimeter. This space will be filled with a fluid on which the cell count will be performed. Accurate cell counts depend on the quality of the equipment used, as well as using proper technique. Each platform is etched with a large grid measuring 3 millimeters on each side. This large grid is subdivided into 9 1 millimeter squares. Each square is subdivided into various additional squares for additional utility. The first step to correctly loading the hemocytometer is to ensure that it is immaculately clean. Any debris left can negatively impact the optical quality of the chamber and cause incorrect results to be obtained. The chamber is cleaned using isopropyl alcohol and lint-free tissue. The cover glass should always be handled by its edges. To begin loading the chamber, the cover glass is placed on the hemocytometer so both sides of the chamber are covered equally. Next, the diluted specimen is mixed gently but thoroughly, and the first few drops of liquid are expressed into a tissue. While maintaining pressure on the specimen vial, the next drop is applied to the V-shaped groove at the junction of the cover glass and chamber. Pressure is continuously applied to the vial and the pipette is held at a 45-degree angle. The slight pressure on the vial will work with the capillary action of the glass to properly fill the chamber. Watch carefully and remove the pipette from the chamber when it is completely filled but not overfilled. If fluid flows into the moat, the chamber is overfilled and the chamber will have to be cleaned and the specimen reloaded. If it will be several minutes before counting can occur, the chamber should be placed in a moist chamber. This can be created by placing a damp filter paper in an empty Petri plate raised on pieces of wooden applicator sticks. The hemocytometer is allowed to sit for 1 to 2 minutes to allow the cells to settle for counting. The chamber is carefully placed on a microscope for counting.
Kung nag-count ka na dito, you count another counting chamber dun sa kabila. Then, get the average of the two counting chamber. Okay, I think napakadali lang naman, no? Sa RBC, lalo na sa RBC. So, kung ito lang ang nababasa niya muna. Then, i-move mo yung stage, no? Papunta dun sa other counting chamber. You have to count 2 counting chambers. Dalawa ha, i-count mo yung dalawa because you will be averaging the results on each counting chamber. So as you can see here now guys, yung itong mga purple, ito yung WBC counting area or counting squares. Again, in each WBC counting square, how much is the total area? That's 1. Okay? 1 mm. Pero pag lahat yan, 4 na yan, so 4 mm. Okay? And what about your RBC? Si RBC naman, 5 na maliliit. Okay? That's 0.25. 0.25 ang area ng isang RBC counting square na yan. So, since 5 sila, so 1.25 all in. Guys, is ito pa lang. Ito pa lang. Yun. Ito pa lang ang na-count natin. Isa pa lang. So, 22 yun. Okay? I-count mo pa dito, i-count mo ito, i-count mo ito, i-count mo ito. And then, you add all of them. Tapos, pag na-add mo na siya, ang gagawin mo, sa kabilang counting chamber ka na naman. So, WBC. Lalong-lalo na sa WBC kasi so, if the cell touches both the mid and the outermost boundary, include it in the counting. So, as you can see here, no? So, merong tatlong line. 1, 2, and 3. So, tatlo siya. So, lahat ng cell na tumama sa second line and the inner line, kasali mo siyang i-count. But if nasa outer line siya, like pang tatlong line, hindi mo na siya kailangang isali. Okay, for two-line boundary, count the cells that touch up to the second boundary line. So, see figure 2. Ayun na nga, yun yung sabi ko. So, up to the second boundary line. So, tingnan nyo dito. Dalawang boundary line lang to, di ba? Yung figure 1, tatlong boundary line. Pero still you counted the second and the first boundary line. The same with your figure 2. Although, dalawa lang ang boundary line na makikita mo, imaginary yung third boundary line. So, hindi mo na to i-count. Ang i-count mo lang yung tumama sa second and the first boundary line. WBC, malaki ang kanyang cells. Malaki ang kanyang squares. And for the last one, whether the box has 3, 2, or 1 boundary line, do not count any cells that touch the right and lower boundary line. So, ibig sabihin, wag mong bilangin yung cells na nag-touch dito and dito. Kasi ang dapat mo lang bilangin is the inverted letter L. Okay? Inverted letter L. If you will try to understand, medyo what it is trying to tell us lang naman is para hindi mo ma-count ulit yung cell, you need to have a systematic manner of counting it. Okay, now, again, this one is serpentine direction. We call it battlement technique. So, for the serpentine direction, start from the upper left corner box going to the right. So on and so forth. Okay, wait, ha? Sige ha, another example tayo. For example, this one, inverted L. So, ilan ito sa first square? You try to answer bago ko isulat ang sagot. So, 1, 2, 3. So, 1, 2, 3. So, 3 ang first square. How about the second square? Ilan? 1. Okay. How about the third square? 1, 2. Ito, nag-touch na siya sa next line. Sa baba. So, hindi na to kasali. So, dalawa lang. 1, 2. Dalawa lang siya. Okay? On the fourth na square. So, isa lang. Kasi ito naman, nag-touch na sa, hindi na siya inverted L. Basta nag-touch siya sa line na hindi inverted L, then it's not included. So, what about this one? So, 1 ito. What about this one? 0. How about this? 1 pa rin. How about this? 2 na ito. So, tingnan nyo. If tama yung ating counting. Teka, sorry ha. I forgot to notice. Okay, wait lang. I have a mistake. Okay, clarify ko lang ha. 'Di ba kanina ito guys, hindi natin to kinount kasi nga dapat dito na siya i-count sa. So dito hindi yan 0 pala, 1 yan. Okay? Kasi itong cell na to, you counted it together dito sa square na ito. So sige lang. The last time I did this one was 4 years ago pa. 4 years, 5 years ago. So anyway, mamamaster mo naman to pag paulit-ulit mo siyang gagawin. Okay? Basta the point is, you have to count the cells sa inverted line. Once it touches not the inverted line, like this one, ito dito, hindi mo na yan ka-count. Okay? So, let's proceed. So, 21. 21 siya, pero isang RBC counting square lang ito. Remember, 5 yan lahat, no, sa isang counting chamber. Okay. Tingnan mo to. So, count this. Bilangin natin, ha? Try natin bilangin. Okay, so you try to count, ha? Saan? Try to count muna. Pause the video, count the total number of cells, and then we will check if tama ang sagot mo. Okay, so once you are done, so try na natin bilangin. Yung mga naka-red, guys, that's included. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Ulitin ko. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47. Ayan, nalito na ako. Basta the point here is that bilangin mo lang kung ano yung nandyan. Okay, nahihilo na ako sa karami. Okay, so basta ang point is, pag ganyan yung bilang mo dapat. Okay? So, ito, bibilangin mo lang to. Teka lang. Bilangin mo yan, gawin natin kulay green. So, this red cell here, hindi mo yan isasali sa bilang mo sa square na to. You will only include this red cell dito sa square na nasa baba. Okay? Kasi nga, inverted L lang. Lahat ng nag-touch sa inverted L, and lahat na nasa space, it will be included in your counting. Sige. So, sa WBC, ganun pa rin. It's the same thing. Same manner. No, yan, oh. Look at this one. Hindi binilang. Ito, hindi rin binilang kasi nasa third na siya. Oh, ito. 1, 2, 3, 4, 5. So, ilan yan? 5 lahat. 5. 0, 0, 1, then so on and so forth. So remember, ito yung 4 na areas where you need to count for the WBC. Now, dito na tayo sa computation. Sa computation naman, so you have to memorize the formula. So, in calculating for cell count, the total number of cells per cubic millimeter or microliter of sample can be obtained using this formula. So, the number of cells counted, remember, meron kang 2 counting chamber, tama? So, in the 2 counting chamber, yung nasa likod and yung nasa harap, so you have to get the average. And yung average nun, yun yung ilalagay mo dito. Okay? The dilution factor, for example, ang dilution factor ng RBC mo is 200, tama? Ang WBC is 20. So, if it is a WBC counting, then ang dilution na gagamitin mo is 20. Pero pag RBC counting, 200. Depth factor, yung depth kanina, di ba? So, in this case, you're going to use all the time your 10. Kapag nasa taas siya, numerator siya. Pero pag nasa ilalim, nasa denominator ang depth factor mo, so your depth should be 0.1. Okay? And the area counted, tinuro ko na to sa inyo kanina kung paano i-compute ang total area. So, if you counted the 4 squares, so 1, for example, WBC, 1, 2, 3, 4. So, in each square, meron siyang 1 mm. Tama? Okay, so there are 4 all in all. So, 4 dapat yan. For the WBC. Okay? So, the same thing ang gagawin nyo for the RBC. Okay, so for example, this one, the WBC counted is 96. So, 96 times, what's the dilution factor? So, since dilution ng WBC ang ginawa, so 20 ang ating dilution factor. And our depth factor is always 10 kapag nasa numerator, divided by the total area counted kasi WBC counting ito. So, 4 mm. Wala ka ng depth factor sa denominator kasi nasa numerator naman ang depth factor mo. Okay, sige. So, itry natin ha. So, that's 96 times 20 times 10 divided by 4. So in this case, your total WBC count would be 4,800 per cubic millimeter. Okay, or if i-convert mo to into microliter, that's 4.5. 4.5. Yan, so 4.5. Remember, the normal value for WBC is playing between around 4 to 10. Okay, so 4 to 10. So ang ating pasyente, sakto lang yung WBC count niya. Ayan, meron palang formula or solution. Sige, ipakita natin. Okay? So, again, what you did here is that 96 yung cells na na-count mo. Remember, get the average of the 2 counting chamber. Hindi pwedeng isang counting chamber lang. So, 96 multiplied to the dilution factor, which is 20, divided by total air counted, which is 4, and then your 0.1, which is your depth factor. Naging 0.1 siya kasi nasa baba, nasa denominator. Pero kung nasa numerator mo yan, ang mangyayari is magiging 10 yan. Okay, so 96 times 20 times 10 divided by 4. So 4.8. Yan, ito yung sinasabi ko kanina. 4.8. The normal value again is 4 to 10. Okay, again, express with 2 decimal points for RBC count and express with 1 decimal point for the WBC count and no decimal count for your platelet. So, let's proceed with the allowable variation in count. So, sabi dyan, whether RBC, WBC, or platelet, both sides of the counting chamber should be counted. So, yun yung sinabi ko kanina. You have to count the counting chamber na dalawa. Okay? And then get the average of the two. So, the counts of the two sides need not to be exactly the same. There is an allowable variation. The counts of the two sides of the hemocytometer should agree by 10% or less. So, for example, if sa unang counting chamber dun sa kabila, and this is the other counting chamber, if naka-count ka ng 100 cells dito, tapos dito sa atin namang other, counting chamber 85 lang, so, anong gagawin mo? Sakto ba to? Hindi. So, hindi siya nag-agree by 10%, di ba? So, 100 dito, then 85 dito. So, nasaan yung remaining na 5%? Hindi siya 10% ang agreement. Sumobra siya ng 15% ang difference. So, in this case, what you're going to do is to repeat the whole procedure again. Ibig sabihin, nagkamali ka sa pag-charge ng hemocytometer or nagkamali ka sa pag-dilute. So, again, the difference between the one counting chamber and the other counting chamber should only be 10% or less. Is get the difference muna. So, tingnan mo, 325, 345. So, isang counting chamber 325, yung isang counting chamber 345. So, ang difference nila is 20. So, yung 20 na yan, i-divide mo yan sa average ng dalawang counts. So, 345 plus 325 divided by 2. So, your average is 335. So, ang mangyayari is 20 divided by 335 times the 100, which is constant. And then this one is your variation, 5.97. So, allowed ba? Yes, acceptable ang variation because it should agree by 10% or less. Less than 10% yan. Okay, dito naman, for standard leukocyte count within the reference range, there should be no more than 15 cell difference between the highest and the lowest number of cells found among the 8 corner squares counted. So, this is for the WBC ha. So, ilan ng squares lahat na na-count mo? Diba 8 lahat? 4 sa isang counting chamber, then yung sa kabilang counting chamber, 4 na naman. So, again, for the WBC, 15 cell difference lang. For the RBC, 20 cell difference. Okay, 20 cell difference. So, anong ibig sabihin yan? Okay, so, for example, WBC counting. So, sa first square, 25 ang na-count mo. Second square, 15. Third square, 22. Fourth square is 17. But this is only for the first chamber. How about in the second chamber, yung nasa kabila, nasa likod? First square is 35, second square is 27, third square is 29, and the last square is 30. Ilang square lahat ito? So, 8, no? 8 squares lahat. So, the highest count in all squares is 35, while the lowest count in all squares is 17. So, 35, okay, 35 minus 17. 35 minus 17, the difference is 18. Oh, WBC. Anong sabi natin? Pag WBC, ano daw ang kanyang difference from the highest to the lowest count? Diba sabi doon 15? So, as you can see, 18 is more than 15. Okay? It did not meet the standard leukocyte count. Okay? It did not meet the standard leukocyte count. The difference between the highest and the lowest total number of cells found among all the 8 1 millimeter corner squares counted should not be more than 15 cells. So, ito, 18 ang difference nila. So, tingnan mo lang saan ang pinakamarami na count, 35. And then, yung pinakamababa, which is 17. Actually, may 15 nga, oh. Siguro hindi to nakita. So, if you will try to check, 15 talaga ang pinakamababa. So, 35 minus 15. Lowest in all 8. 15 yan eh. 35 minus 15. 20. 20 ang difference, which is, again, far or way more than the 15 cell difference allowable for WBC counting. So, next, we have your aftercare of hemocytometer. Ibig sabihin, what to do if tapos ka na. So, first is clean it with water or if necessary, a mild cleansing solution. So, dry it with soft cloth or rinse it with acetone. Yan ang sinabi ko, acetone. And you don't need to wipe off the acetone kasi mag-evaporate lang yan. Okay? So, lastly, kindly read the page 46 of your laboratory manual for additional notes. That's the end of the pre-lab discussion for your hemocytometer and your WBC and RBC manual counting. If you have questions, please do not hesitate to ask. We will be happy to answer your questions, particularly in the manner of counting the cells. Baka na-confuse kayo dun. But for the dilution, of course, it will be easy if na-perform nyo talaga. So, next week, we will be performing it naman. So, you can be able to, at least somehow, when you check for the procedure, ginagawa mo siya. So, mas madali mo siyang maintindihan. Okay? So, that's the end of your pre-lab discussion for hemocytometer.